Okay, let's do it.
Sounds good.
All right, well, welcome. My name is Curtis Brown, and we are chatting about the 2024 TI Codes contest. We've got a former winning coach here, Debbie Moss, with us. I'm really excited to have you, Debbie, and I've also got Harshal Chhaya, who's a engineer here at Texas Instruments, along with me. My name, Curtis Brown. I'm a math teacher and now turned math specialist here at TI. And I'm part of the STEM team that's who hosts this TI Codes contest every year. Harshal, I'll let you give yourself a quick introduction, and then let's get Debbie started talking and going.
Absolutely. Hi, everyone. I am Harshal Chhaya. I am a systems engineer and a product manager at Texas Instruments for all of our STEM and coding projects. So I work with educators like Ms. Moss here and others to, come up with ideas, define the products, and then design them. And I have been involved with the codes contest for a few years now, and I'm really excited every year to see what the students come up with, and really looking forward to the upcoming contest.
Fantastic. Debbie, would you introduce yourself and give us a little bit of background on where you're from? And
Well, hi, I'm Debbie. I currently here in San Diego. I spent 20 years in the Navy before retiring and starting to teach at a local community college here, as well as Sky High.
fantastic. Fantastic. And Debbie, I think you also coached a team to win this past year, wasn't it? This 2023 year?
Well, our teams win every year just by participating. I just want to point that out. But
Fantastic.
we have had teams in the past 5 years. We've had 4 teams in the top five. So
Fantastic.
yeah.
That's great. That is really, really great. Well, one of the things we wanted to do this evening was create sort of a video here for teachers and coaches who were thinking about maybe hosting one of these teams and getting them started. So let's start off with just any helpful tips that you would like to share for folks who may be thinking about starting a team.
Uh, just do it. I mean, honestly, what do you have to lose? There is no cost. Really, there's no cost to enter. You don't have to have any supplies. If you make it to the build phase, TI sends you everything. Texas Instruments wants you to participate and they want you to succeed. So they give you the stuff, they support you every step of the way, and you don't need to know anything about working with Texas Instruments calculator, innovator hub, microbit. You can go on their 10 minutes of code website, and probably with, if you have a class period or an after school club, within maybe 2-3 meetings, you will have, not you personally, y'all will have figured it
There you
out
go.
together, the basics that you need to understand how everything works. And along those lines, I don't know if it's too late this year, but once I figured out points of contact within TI, they have a really robust loaner program. Uh, not not just the big stuff, but if all you want is a calculator and an innovator hub, I'm guessing that's something. I don't want to make promises on you guys' behalf, but I feel like those are things that are easily at hand, that even if they don't come from big TI, probably your local rep could just let you borrow or could come by and show your team how it works for, a class period or something.
For sure.
So,
That's
that's just, first of all, is just jump in and do it. And then the second thing is the programs that end up running the projects that you can see on the previous year's websites, they're so short. They're 20-30 lines of code. These are not, you know, we the teams that write these things, they may be very smart young men and women, but the way that the Innovator Hub and the Microbit and the Inspire and the 84 work with either Python or TI Basic, it's, it's not a lot of code to make amazing things happen, I guess is the easiest way to say it.
That's a really good point. The
Uh, uh,
short programs seem to be uh, the ones that end up winning. They've got really simple, kind of short and to the point. You can do a lot with a very short amount of code, and I think that's an important piece. I think you bring up a really excellent point that you don't need to have a background in engineering. You don't need to have a background in code or programming. There's a lot of good supports ready to kind of help you get over the hump and get your students going.
Well, that's honestly, I get in my students' way when I try to bring my background into it. Like, there's a tendency to want to solve their problems for them with fancy solutions, either coding or electrical or engineering solutions, and it overcomplicates it, and then they don't understand their own project. And you'll show them something fancy, you'll come back 20 minutes later and they've taken it apart and found a simple, elegant solution. They've deleted the fancy line of code that you showed them and found a simple, elegant solution. And so you just learn not to do that and learn to let them solve their own problems. And it's much better for everyone. So I think honestly, you're in a better position if you have less background and you just learn with them and facilitate rather than trying to teach or help.
yeah, that's a good point. Is just the students, they'll use the tutorials and they'll figure things out on their own. And sometimes things we are sometimes amazed is when they ask us questions about how do we make this happen or how do we make that happen, and they really have some thoughts that maybe we haven't even considered, when we design the product. But they sometimes come up with some really innovative ways to solve the problem.
Sure.
So one sort of follow-up question is, I know you've been participating for a few years now. Are there things that you know now that you wish you would have known when you started, or something that you think a rookie coach uh, should know? I think you already mentioned a couple of things. One is let the kids figure stuff out, or I mean, but are there other things in terms of just logistics and scheduling? Other things that you think might be somebody should know those.
Yeah, I think the very first year, I think, the students tend to, they pick up your vibe, right? And I was terrified. There's a packet that you have to fill out. I assume that the contest kind of follows the same lines every year. And there's a 5 or 6 page packet that you have to fill out. And when you first look at it, it is so intimidating. I mean, it's not actually, but when you first see it, it looks intimidating. So you look at it, you feel intimidated by it. The students pick up on that and they're intimidated by it. Because if you've never seen a TI Innovator Hub, if you've never programmed on an Inspire or a TI-84, and then you're asked to fill out these essay questions and make a wiring diagram and attach a JPEG to this PDF packet, you ask yourself, what have I gotten myself into? But I think the important thing is that it doesn't really matter. I don't want to say it doesn't matter what you write in there. It doesn't matter what the students think they're going to build. They're never going to build that. What matters is that they follow the engineering design process. So they think of a problem. They think of what the requirements are. They think of an engineering solution that's going to address that problem. They put together some kind of a reasonable, rational idea using some TI parts that are in the handout that they get from you that they think will be a solution to the problem, and they turn it in. Now you're going to look at it, I'm guessing, I have no idea, I've never been on your end. You're going to look at it and say, that will never work, but I'd love to see them try. And that, I think, is how they get to the next round. Because I know the first year we participated, there was no way that what my students submitted would ever work. At the time, I didn't know that. But now I know that what you're really hoping is that students will learn through this process, not that they'll submit a perfect packet when they submit it the first time. So that's why I say it doesn't matter if you're an English teacher or an engineering teacher. Coach your students through finding a problem, thinking of requirements, thinking of solutions. Have them fill out the packet to the best of their ability, regardless of what their ability is, and just submit it. You're looking for interest, not ability. You're looking for a great idea, and then you're hoping that through the contest, they will realize where the problems lie and solve them. I hope that made sense.
It did. That's a perfect. I love what you said, is just getting the students over the hump of I'm intimidated to get started. Once they get an idea on paper, that's the most important piece of the puzzle. And you're exactly right. We are absolutely just looking to get students involved, to get students trying things. Because as they go, they've proposed an idea and they realize partway through this, as they're drawing their design, or maybe they've gotten into the build phase and they go, oh my gosh, that isn't going to work. Then they revisit the plan, right? They follow the process. They go back through and they go, oh, well, what can we adjust? And here's how we're going to make this adjustment. And now we're going to do this a little bit different. And oh, now that part works. Harshal, as an engineer, I'm sure that makes a ton of sense, right? It makes your heart sing to think about that whole that iterative process.
Absolutely.
Design, build it. Oops. Design, build it.
Yeah.
Oops.
Yeah.
And
And that's exactly what we do when we do product design is, we start off with something that we think would work, and oftentimes it doesn't quite work. And then we go back and we refine it. And that's exactly what these students are following. And it's wonderful to see that. And you're absolutely right, is when we first see the initial submission, there are definite cases where it's like, yeah, okay, this is a very interesting way to look at things. It'll probably never work, but
right.
let's see where they take this, because as they draw it on the paper the first day or the first round, that's just on the paper, and lots of things look perfectly logical on paper, but you're right, and it's part of it is just seeing them go through the iterative design process and improve the design to get to something that's working, and then write the code to make it work, do the electrical design to make it work. I mean, all of that is one of the things I like about this project, this contest, is that it's not just software, it's not just hardware, it's really making them talk to each other and making things move and talk and move, just all of them.
There's a lot of great soft skills in the middle of this project that are really important, along with all of the other piece of it. So a couple of things, maybe, Debbie, as you are thinking about this contest and things that maybe you'd pass along to folks, what are some things that you've done or that you did early on that seem to help engage students with the project, to maybe help build the team, or maybe multiple teams? You've mentioned that you have several that you give advice to.
So like I said, the very first year I had no idea what I was doing. So I thought, well, we have to start somewhere. And the first year of the contest was 2018. Our first year was 2019. So fortunately, there was something available. And thank goodness, you guys are so good keeping records. All of the 2018 videos were up on the website. So the first thing that we did was we took a day of class and we went on the website and we found your grading rubric from 2018 in the contest rules. And we found the videos from 2018, and we had the students act as if they were the TI judges. And they went through and watched all of the videos and graded all of the videos and ranked all of the videos.
Oh, wow.
And the pretense there, I told them that was that I wanted to see how they did compared to how you did and how the contest results came out.
I love it.
My actual goal was to get them thinking about what they like and what they dislike in making a video, but more importantly, I wanted to see themselves on the screen because the whole idea of the project is intimidating. After watching the videos, they were saying things like, oh, we could do this, we could do this. Here's an idea I have. They weren't even thinking about what project they would do. They were thinking about video production. Oh, we could have background music. Oh, we could get, we could involve so and so in the storyboarding. We could do this with our, oh, it's great. We really like it when when they talk too fast, it doesn't sound good. We can't understand what they're saying. If the music is too loud, it overwhelms the description of the item. I mean, they're just picking apart what makes a good 90-second video and what makes a not as good 90-second video. And they were saying we.
I love
So they're already seeing the final product with them in it. So that's just one of the things that we do.
Very cool.
That's a really good idea. Yeah.
I
So,
love thinking about
Curtis,
previous year's
yeah.
ones too. Go ahead, Harshal.
No, I was just gonna say, Curtis mentioned some soft skills, that we've seen the teams develop, and I think we've heard from some of the coaches. So, are there specific, skills that other than just coding and engineering, that you saw your students, get better at through the course of the project?
Well, just to clarify, this is an all boys school.
Okay.
One of the things that I think sometimes we struggle with is empathy. Being young men, sometimes it is difficult to see things from the perspective of another or to say something kind. And I think through doing this project where we all have the same goal, rather than being so focused on our own grades or passing our own exam, noticing when somebody else has moved the project forward towards the next goal, even if it's something small, or when we put a team together, sometimes there's so much focus on who knows how to code or who knows how to build a good electrical circuits. They're not thinking at all about the fact that one of the requirements of the contest is that the model or prototype look good. And you suddenly realize that someone on your team has quite the artistic flair. And just being so appreciative of that, saying, I had no idea that you were such an artist. Or suddenly realizing that someone on your team is a marketing genius and is able to storyboard and build the perfect commercial. And no bones about it, this 90-second video that you have to make is a commercial. It's an elevator pitch, a commercial, whatever you want to call it, but you have to say everything about this product in 90 seconds, how it works, why it's important, in this 90-second commercial. And so you have some real marketing geniuses that if you're maybe a math teacher or a chemistry teacher, you have never ever realized, and your other students have never realized either. But especially if you make it to the last round where it's all about getting votes, and if you come from a small school like mine where we have never had more than 3 dozen students in 9 through 12, getting the vote out and being able to come in first place ahead of some schools with 3,000 students, that is a real marketing genius who can get out that vote.
It's an important challenge. and a
And
difficult one. But I think that's awesome to think about that. I noticed we chatted a little bit earlier. You also mentioned some other things that you've seen your students grow in about resilience. And
oh, well, this just goes back to the whole idea of that engineering design process, right? Um, the the project the projects never work, and then they work, and then you turn the video on,
yeah,
and the Venn diagram of when the project works and when the video is on are two circles.
Like,
yeah,
yeah, two disjoint seconds. Yeah, yeah. I've been there, done that. Not
very
press the record
much.
button in time. You're absolutely right.
It worked. We
and
turned the video on. Nope, it didn't work.
and talking about then seeing students who were at the beginning of the year, struggling with empathy and with not being able to form a team and with saying unkind things to each other, to towards the end of the year when this video had to be made. You have a 90-second video, it has to be filmed, it has to be edited, it has to be delivered, to encouraging each other to say, okay, let's do one more take when you're on the 23rd take. All right, guys, let's reset. Let's, back to places. It's going to work this time. Hey, man, you're doing a really good job. No, you built it perfectly. It's not you. It's not the wiring. It's not the code. We're going to get it this time. Saying such encouraging things to each other when, I mean, sorry, I'm almost going to cry. You know, there is no negative talk, no negative team talk, no negative self-talk. It's just, let's just reset. We're going to get it. This is the time that we're going to get it. And it still doesn't work. So we're on to take 24. These are skills that we need in life, right? Because some days that happens. Some days you get up and you have a job interview and you have a flat tire, and then you get a speeding ticket, and then you spill your coffee on your shirt, and it's just one thing after another, and you still have to get through the day.
I love it. I love it.
Yeah.
Well, one
Wow.
of my
Wow.
favorite parts of this contest are the phone calls that we get to do with the teams, where Harshal,
Oh, wow.
myself,
Yeah.
and a crew of folks, of experts from engineering and mathematics, science, all kind of get on the call with these students, and we get to listen to their plans and their team and their questions. It's one of the key things that makes me want to continue coming back every year to do this contest. So can you talk a little bit about those conversations and where that
So
takes?
this is one of my favorite stories, and this goes back to what I said about getting out of the students' way and let them solve their own problems. The very first year we did this contest, uh, the students wanted to build a flower pollinating robot. And the way they
I
wanted to see
remember
the
that
flowers
one.
was using a color sensor. Well, uh, most, unless it's been built into the innovator, like a library has already been added to the innovator, you can't use a sensor. And I tried to, I explained it over and over. Like when we start out the class using Arduino, where you can just download a library, add it in, and if you use the launchpad outside of the innovator, you can do the same thing. You can add libraries in, but once it's locked into the innovator, right, you can't do that. You're not coding. You're just talking back and forth with the calculator. And so they were a little bit frustrated by that, but the project manager on that particular project said, "No, I have made a decision. I'm the project manager. We're not going, it's too late in the project at this point." Sounds exactly like a project manager, right? Uh,
It does. It does.
right? Uh, uh, we are sticking with the color sensor, and I know it will work. because I have seen this color sensor on the bottom of the rover. And if it works on the rover, there has to be a way to make it work. And I feel like that's exactly what he said in the meeting with the engineers. And here's what I love. This was before Zoom. This was in 2019, pre everybody using Zoom. So it was just a phone call. But they treated him, you treated him just like a fellow engineer. It wasn't a kid talking to a bunch of adults. It was a group of adult engineers having a conversation. He had his team, TI had their team. He was saying what he wanted. They were saying, okay, run and get a couple of these wires, grab this, grab that, let's see what we can do. Real time, they were solving the problem. And that's my experience every year during these calls. It reminds me exactly of when I was in the Navy and we were having troubleshooting meetings between groups of engineers and just solving problems. This is one of those experiences I don't think these guys get anywhere else in their education, to be treated exactly like a member of a working team. And just to make this circle complete, during the consultation this past year, our team was on a call and they said, oh, I remember you guys. 5 years ago, you were the team with the color sensor. Now, nobody in the school this year attended this school when the team with the color sensor was here. But this is something that would happen at a fast-moving company, right? Where you get some turnover because people are moving up or they're moving on to other projects. And these guys knew, because we know our own history, we know our corporate history. We're the color sensor guys. We're the automated dog food dispenser guys, right? We
Right.
know our corporate history. And so they said, yeah, we are. We're the color sensor guys. It was just so fantastic
I love
to
it.
be treated like adults. And I can't even describe it. I don't know. It was pretty amazing.
Yeah, and that's exactly because these kids deserve that respect. I mean, they are solving problems that we would solve probably in a totally different way, but they come up with a proposal, a solution that we really want to succeed. And we are very impressed when these, by all the designs. And some of them get refined, some of them get tweaked during our discussions, during our calls. But a lot of times we walk away thinking, oh, that was an interesting way to use, this product or this code or this whatever it was, that maybe wouldn't have thought of it. But these kids, because they've spent all this time, these young men and women, they are thinking differently, and that's really worthy of respect and admiration. And so we, as Curtis said, we enjoy these consultations. They make us think. They make us, scratch our heads and say, yeah, maybe we didn't think of something. Maybe these guys have the right approach. And so that's truly one of the great experiences that we have with talking to students, and it's always a pleasure.
Well, as I think as we're nearing the end of our time here, I think, Debbie, you've mentioned a few past results or past projects that have kind of been done by some of your students, and some of the ones that maybe spoke to your students. I know I can think of one from a previous year. I can't remember what year it was, but we had a group that somehow figured out how to get 6 of the motors together, so they had the axes to make a robotic arm, and created a functioning and working robotic arm that could move and grab things from basically inside of a cube. It was a pretty incredible project. There's been some incredible projects that have gone through this process. So I'll give you, Debbie and Harshal, one chance to shout out a couple of videos for folks to go and look at, and then we'll sign off here.
So I'll just go. The one I enjoyed was the 2022 winner. They ended up winning. It was a middle school project, and it was a device, a radio system that was used for dog training. And the thing I loved about it was they actually found a trainer, in their community who works with dogs, and had that person try this system out. And they recorded the video and they interviewed him, and how this would work. And so that was a really, sort of, they demonstrated the product, their product, but they also got an expert or someone who would potentially use this to talk about it. And they used a combination of technologies. They used the Innovator Hub, they used the microbit, they used just lots of different sort of things coming together. Actually had a working prototype that was used by an actual dog training. So that was just something that, and this was by middle school students. So that was kind of an interesting, kind of thinking beyond just, let me just do something in my lab, or let me just do something in the classroom. That was something that was really, something that we hadn't thought about or we hadn't seen before. So that was one that I love. And there's lots of different videos. So I think what Debbie said earlier is, if you are thinking of participating, go look at some of the previous videos. That'll give you an idea of what other people have done, what can be done. Lots of open-ended engineering projects there. So that's definitely encouraging to go see those videos. Debbie, you have the last word here.
Well, if you don't mind, I'd like to do one of our students' projects, and then another group. We just went and watched dozens of previous videos, and yes, there are dozens of them up on the website from previous years. And because this year's theme is safety and security, the one that jumped out at them was there is a project having to do with car brakes that they found. It really spoke to them because they thought that the project itself, how it was implemented, was great. And not only that, the way it was presented in the video, they thought was really well done. So if you're looking for just one to start off with to show your students, like, this is an example of a really well done TI Codes project, that's the one to start with. And then one that I really liked, because I think that Harshal will attest that I enjoy when my students try to get around the limitations of the Innovator Hub. But this is not just a limitation of Innovator Hub, it's a limitation of microcontrollers in general, is that you can only generate one PWM signal at a time. You can only, for example, turn on one tone. My students wanted to do, for the health project, which was, I think, 2021, you can only, they wanted to do something called binaural beats, which generates two tones at a time that are slightly separated frequencies. And you just cannot do that on a microcontroller. So what they did was they told it that one of them was an LED. They turned on a light, but when you turn on a light, it generates a frequency that if you, instead of plugging in an LED, just plug in a speaker to it instead, it generates a steady tone. And I had no idea. They're like, hey, look what happens when I tell it I'm turning on a light, but I plug in a speaker here instead. And I was like, I had no idea, but apparently they did.
That's fantastic.
I know that was really cool. That was one of those things where we're like, oh wow, you can do that. That is really interesting. And that was
well, you can't play a song, you can't do anything fancy, but it worked for what they needed it for. And so I said, hey, if it didn't do what I expected, but it did something you needed, so keep doing it.
That's
exactly right.
I mean, that's one of the ways that you end up solving problems, right? Is they came up with a solution that they used something in a way that it wasn't really designed to be used, And they came up with a working thing for what they intended to have. And that's one of the great things about this project is these are prototypes. The kids make a video about that prototype. They market it and sell that prototype. So even the ones and I'll say this kind of maybe as a final closing thing, is that even the ones where the students come up with a project and ultimately it doesn't quite work the way they thought it would, or they didn't get everything done by the time the video was due. We really truly appreciate the students who continue to go ahead on and produce that video, talk about what they learned, talk about what they've seen, and show us the project as complete as it possibly could have been, and explain what kind of they felt were the places where maybe it didn't work and what did work. Those efforts are always highly appreciated as well, because ultimately, like you said, Debbie, the goal for this is that students are learning and growing in their engineering interest and skills, and the skill set that come along with that. So Debbie, thank you very much for taking time out of your evening to come and chat with us. Harshal, the same. Thank you for joining this evening. We really look forward to having everyone join us in the 2024 TI Codes contest as we get ready to launch
just about a month from now.
a little bit. Well, have a good night, everyone. We'll see you next year.
Right.
Thanks, Curtis.
Thank you. I'm looking for my end the stream button. There we go. All right, guys, that was it. We are ended. Our video